Good morning. I have no idea how it's going to go. I've got Jovi in the background, I've got dogs in the room, but we'll give it a go and see what happens. So I wanted to talk you through a couple of the more theoretical things from today in terms of the interior of the Earth and the Earth's makeup and that sort of stuff. So there's some stuff from GCSE that you might remember, those of you who did GCSE. And essentially, if we were to draw the Earth and cut it in half, in the centre there would be an inner core. The inner core is affected by the Earth's gravitational pull. So the middle of it is so compact it becomes a solid in the middle. It's mostly made up of iron and nickel and other metallic elements. So it's very, very dense, very, very heavy, very compact and very metallic. Around the outside of the inner core, we have the outer core. Again, lots of metallic elements, so mostly iron and nickel. The difference being this one's not under so much pressure and is actually in its liquid state. If we didn't have this in its liquid state, we wouldn't have a magnetic field, so it's a really important part of the interior of the Earth. That's not relevant to the actual course, but just interesting bit of knowledge. So beyond that, we have quite a large area, which is the majority of the interior of the Earth, which is called our mantle. And those of you who didn't do GCSE, it is spelt like that. And it's a very, very large section in between the liquid outer core and the bit that we live on the outskirts, which is obviously the crust. So obviously we have a very, very thin layer around the Earth, which is our crust, which of course is solid. Now the mantle doesn't fit into solids or liquids, sadly. It's kind of somewhere in between. And it's what we call semi-molten. Or you might see it written partially molten. And what that means is molten rock is liquid rock, so it's so hot that you can pour it. The mantle is not, it is obviously incredibly hot, but it's not molten, it's not liquid, it hasn't completely melted because it's under the pressure that it's under. It behaves a little bit like a liquid, a little bit like a solid. The best example I can give you is a little bit like a Maoam bar or an iron brew bar if you used to have those as kids. It's kind of solid, but it's pliable, you can move it. Or something like plasticine or blue tack or something like that. It's kind of in between a liquid and a solid. You can mould it, you can move it and manipulate it, but you couldn't pour it like you could a liquid, and it's not completely rigid like a solid. So that's kind of the very quick GCSE version of what that is. We didn't talk about elements as we come further out. So we still have lots of metallic elements in the outer, the crust and the mantle too. We have other things like silica that kind of make up more of the composition as you get further out, hence why the crust isn't completely metal. It's actually got other elements in it too. But again, just a little bit extra information. So sadly, GCSE is far away and we have to do it in much more detail than that. And so to do that, I'm going to show you a slice of the Earth. Again, it will have similar components. So at the bottom here, we've got the inner core. And like we said, that is in its solid state. At the centre of the Earth, if you're interested, is 6,378 kilometres down. And we believe this roughly starts at about 5,100 kilometres down until the centre. Again, we use waves, seismic waves, to measure the reflectiveness of waves in the interior of the Earth. And how those waves behave when they come back to us indicates what the state is of the core. So hence they're able to actually give a rough value as to where these layers start. Hence it's a very round number because they're not exactly sure, but they're more sure about the centre of the Earth, as you can see from the very precise number. So like I said, iron and nickel, so very metallic, solid in the middle. Then we've got our liquid outer core. Again, like we said, very metallic, and we believe that starts at about 2,900 kilometres down. Again, as we said, that's the best guess at the moment. Then sadly we break up the mantle into some different layers, some of which have names and some of which just don't, which is a bit random. So we have kind of a bulk of the mantle which we don't know very much about because it's quite hard to obviously dig down and survey. So we know this bit of the mantle here is kind of slightly separate to the bit above it, but we don't really know the ins and outs of how and why and what depths and what temperatures and that sort of thing. But we have a layer right at the top which we've actually given a name to. So all of this so far, and there'll be one tiny other little bit. So there's 4 little parts that make up the mantle. And like I said, we said it's semi-molten. That one and that one are just kind of parts of the mantle, no names. But this one has got a specific name, and it's, I'm afraid, a horrible one. So it's called the Asthenosphere. This part's the most important part because we believe this is where most of the movement of the above plates happens. So I know you've already kind of started having a look at plates, and that's part of the lesson today. But we have this crust that sits on top of the mantle, and we know that that crust moves around, hence we get volcanoes and earthquakes. And we believe that most of the movement happens because of movement in the asthenosphere. Hence they've given it a fancy name because it's more important than the rest. Then above that, there's another little part of the asthenosphere, part of the mantle, which it's different. So this part of the mantle here, it is all semi-molten. In fact, what I probably should have done is not put that there. But there's a tiny little part just above the asthenosphere, which is still technically the mantle, which has just become so cool, it's become solid. So this part of the mantle is the only solid part. And again, we don't give it a name. But so I put solid uppermost mantle, and it sticks itself to the underside of the crust. So above that, we've then got, I've done that a bit too big. We've then got our crust, and we've obviously got mountain ranges and stuff like that on there. And our crust is the solid bit that we walk around on, and then attached to that at the bottom is this solid piece of uppermost mantle. We'll talk about this in a second, but I'm just going to put some C onto our diagram because we're going to talk about the two different types of crust that we have as well. Before we do so, I said that this solid bit of uppermost mantle doesn't have a name, and I stand by that. It doesn't have a name, but in combination with the crust, we give those two layers together a name. And we'll mention this a few times through the second year as well. And we call it the lithosphere. Litho translate as Greek or Latin or something to rock, so it's the rock sphere. So hence the rocky bit is the solid bit, it's the bit that we live on. So the solid uppermost part of the mantle and the crust together we call the lithosphere, and I'm afraid that's another word that you need to know. Like I said, we don't really know the depths of these different parts of the mantle. The only thing we do know the depth of is the actual crust itself. And the crust, again, you'll see different numbers in different textbooks because they're not quite decided on the numbers, is between 0 to 100 kilometres thick. So the tallest mountain down to the bottom of the crust is about 100 kilometres thick, but it can be very, very thin. Under the oceans where we have plate boundaries and so on, it can be not even a kilometre thick. So like we said, we've got these two different types of crust. We've got some that are underwater and some that obviously poke out of the water. Hence we get continents and we get the underneath the ocean plates as well. You need to know the difference between those two. So some of them are quite obvious. So continental crust, so this little bit here, you can see is much thicker than the stuff that's underneath the ocean. But also, this is the most important one because it feeds into a lot of what we'll do another lesson. Yes, it's thicker, but it's not as dense, it's not as heavy. The particles aren't as squeezed together. So it ends up being lighter and more buoyant. That becomes really relevant when we start looking at plate boundaries and what happens when two plates come together. Because as you can probably start to imagine, one that is more buoyant is going to be more likely to float or rise above another one, and one that is heavier and denser will sink. So it's the oceanic crust over here that you can see is very, very thin, but the weight of that water over a long period of time has squashed that plate underneath the ocean and made it really thick. Made it really dense and heavy. So oceanic is very thin but very dense, and continental is very thick but very light. There's one more difference as well. Again, have a guess whilst the video's on. Which one do you think is the oldest? Everyone for some reason always says oceanic. I'm not quite sure why. It's not. It's the continental crust, which is the oldest. Think about it. We live on the continent. We live on the land. We have done for many, many millions of years. Think back to the dinosaurs and the different periods of geological time that we have. The land has been around for a long time. It's actually the ocean that is more likely to, one, be destroyed and two, to be renewed. So ocean is always younger than continent. Says your three kind of differences. There's a couple more things that I'm afraid we need to put on here as well. And if you flicked forward a few slides, you may have seen that there are these things called discontinuities. I'm just going to pause just a second whilst I do something, bear with me. Sorry, just needed to get these spellings because these ones are fairly complex as well. So we have in between the different boundaries, like we said, between the inner core and outer core, there's kind of this imaginary line, if you like. These lines, or these boundaries between the different parts of the interior of the Earth, are known as discontinuities. And as and when they were discovered by certain people, those certain people named them after themselves, and they couldn't be just called, John Smith or something easy like that. They had to have complicated names. So in between the inner core and the outer core, we have this line here. This is called the Layman Discontinuity, and it's spelled Lehman, and then discontinuity, because it's not continuous, hence discontinuity. So what I love about geography is a lot of the words kind of make sense. Sadly, the actual names of them don't. So Layman, just the person who discovered it. Then, oh, you're going to love this one. In between the outer core and the mantle, that discontinuity there is called the Taylor. That would be easy, wouldn't it? Gutenberg discontinuity. Again, I won't write the word again, but you know what I mean. And there is one final one, and it's probably the worst one of them all. And that is the bit in between the crust and the mantle. So this bit here between the solid crust and the solid part of the mantle, I'll put a little star there and write it at the top because I'm never going to fit that in. You'll be happy to know that they actually do shorten this, so you don't have to learn the spelling, but if you can, extra brownie points. Isn't that good? It's the Mahorovichik Discontinuity, and we do shorten that and just call it the Moho. Think of Santa, ho ho, moho. That is the last discontinuity, and that is one between, as I said, the crust and the uppermost part of the mantle. That's quite a lot to digest. If I were you, I'd kind of take that away and maybe test yourself a couple of times. Again, if we were in the classroom, what I would be doing is giving you a handout sheet with that slice, and then just a couple of times getting you to see if you can recall it as a bit of a starter activity. So you could kind of facilitate that yourselves if you wanted to. But that is the basics of it. Anything you don't understand, pop me an email, but I hope this helps a little bit rather than just the diagrams that are on the presentation. What I'm hoping to do, as I said in the message that I put up, we're hoping to get something called Screencastify. At the moment, I've only got little 5-minute chunks that I can use it for, but we're hoping to have it downloaded as a college. What I can then do is talk over the presentation. So rather than having to do this and put it separate, I can actually just talk through things and use a pointer on the screen to point things out. So hopefully, fingers crossed, it will get a bit easier to do this as we go further on. But for now, I hope that helps, and I'll see you soon. Bye.